Welcome to this explainer on Maker Skills, the magic of simple machines. We're going to uncover the brilliant engineering secrets hiding right in plain sight inside our everyday objects. I'm absolutely thrilled to guide you through this material today because honestly, once you learn to see the world through the lens of a maker and an engineer, your whole perspective completely shifts.
Now, let me hook you with a pretty simple question. Think about it for just a second. How did doors and windows actually work? We turn doorknobs, we push open heavy wooden doors, and we slide glass windows literally 100 times a day without giving it a second thought, right? But what's really happening beneath the surface there? What are the actual mechanics behind that simple twist of the wrist?
Well, the answer lies in what engineers call a simple machine. Basically, these are tools that make work easier, allowing us to do things far beyond our natural physical capacity. Imagine trying to lift a massive boulder or, break a thick log of wood with just your bare hands. It would be completely impossible. But simple machines allow us to move heavy loads and manipulate objects using just a fraction of the force. It's kind of like having superpowers.
Here is our roadmap for today. 1. The magic of simple machines. 2. The 6 foundation blocks. 3. Building toys from waste. 4. Anatomy of a bicycle. And finally, number 5. Maintenance and repair. Let's get right into it.
Section 1. The magic of simple machines hidden in plain sight.
Seriously, just take a look around your kitchen. A knife cutting vegetables, a vegetable peeler removing skins, doorknobs helping us open doors, or even just a standard spoon popping the lid off a tin. Simple machines are literally everywhere in our homes. They aren't just basic household items. They're the foundational tools of physics in action. Moving on to Section 2, the 6 foundation blocks, the core toolkit of engineering. Mankind has used these 6 foundational machines since ancient times to literally build civilization. First up, the inclined plane. Okay, so trying to lift a super heavy box straight up off the ground and into the back of a truck, that would be totally backbreaking. But by using a ramp, which is an inclined plane, we spread the effort over a longer distance, and that makes loading that box almost effortless. Next is the wedge. This is the absolute perfect tool for splitting hard materials apart. Think of an axe head driving into a log. It takes that downward swing of your arms and transforms it into this powerful outward splitting force that easily separates the wood.
Then we have the lever, which pivots on a central point called a fulcrum. Just picture a playground seesaw. A lever allows someone to easily lift a much heavier load on the opposite side simply by positioning themselves further away from that pivot point. It's the absolute magic of leverage.
Up next is the wheel and axle. And it's not just a rolling circle, okay? It's a wheel attached to a central rod or axle, so they rotate together. This brilliant design perfectly balances heavy loads and allows for incredibly smooth movement over distances by dramatically reducing friction. It's a real game changer. We also have the screw. Now, if you look closely, a screw is essentially just an inclined plane wrapped around a central cylinder. When you twist a lid onto a jar, you're using rotational force to drive it tightly down onto the glass threads, securely fastening the whole shebang together. And we finish off our foundation blocks with the pulley. This is a classic, super powerful tool. By running a rope over a grooved wheel, a pulley lets you change the direction of your force. So instead of having to deadlift a heavy bucket of water straight up out of a well, you can just pull down on the rope using your own body weight and gravity to help you lift it. So smart, right? All right, Section 3, Building Toys from Waste, DIY Maker Skills in Action. Before we start building, let's lock in the mechanics of a basic lever. Like we mentioned earlier, it's a fixed bar moving around a hinge or fulcrum. Imagine applying downward force to the handle of a spoon to pry open a really stubborn tin lid. You're saving your fingernails in the process, right? The edge of the tin acts as your fulcrum, multiplying your force right at the tip of the spoon to pop that lid right off. Now, let's actually build an air balloon car using some simple household materials. Step 1. Blow up a balloon through the open end of a straw that you've attached to a little toy car. Step 2. Press your finger over the straw to trap the air and place the car on a nice, flat, even surface. Step 3. Just release your finger. The escaping air pushes backward, thrusting the car forward. Now, the crucial takeaway here is that as we build more complex toys, like, say, a functioning windmill model, we're actually just combining multiple simple machines so they work together as a team. A windmill takes a propeller to catch the wind and links it directly to a wheel and axle to generate rotational energy.
It's this beautiful chain reaction of simple machines.
Which brings us to Section 4, Anatomy of a Bicycle, the ultimate complex machine.
A bicycle is the absolute perfect way to illustrate this concept. It's basically a bunch of ancient, simple machines beautifully pieced together into one elegant system. The rims support the tires, the brakes and brake pads use friction to grab the wheels to slow you down, the spokes connect the rim to the central hub, giving it massive structural strength, and of course, the saddle is where the rider sits. All of these individual components work together seamlessly to transform your physical pedaling effort into forward motion. It's incredible when you really stop to think about it.
And our final section, number 5, maintenance and repair, keeping machines running.
When it comes to maintenance, there are some really simple, hands-on solutions for common bicycle problems. Like, what do you do about rusting? You definitely don't just throw the bike away. No way. You clean the affected parts using some sandpaper and then apply a nice layer of oil or paint to protect the metal. Got loose parts? Easy. You just grab the appropriate tools and fix them securely back into place. And speaking of tools, here's exactly what you need for routine bicycle maintenance. A spanner set and wrenches for tightening up those bolts, a chain brush and oil for lubrication, tire levers and an air pump for flat tires. Having this exact list empowers you to set up your very own workshop repair kit right at home. You're basically a mechanic now.
So, we've explored everything from the simplest wedge to the beautiful, interconnected complexity of a bicycle. But the true essence of maker skills is putting this knowledge into practice. So, I want to leave you with a bit of a challenge. Design a toy that you can use to help a peer understand a math or science concept. How will you combine these simple machines we talked about? What waste materials will you transform? The knowledge is yours now, so go out there and start creating.